I'm Scott Litzelman. I'm a program director at ARPA-E.
Hi, I'm Max Tuttman. I'm a tech to market advisor at ARPA-E, and I've been working with Scott for the past year and a half on the flexible carbon capture and storage program known as FLECCS. Scott, I know you've been thinking about this for more than a year and a half, so why don't you take us back to kind of your thoughts on forming the FLEX program?
Sure. So carbon capture and storage, or CCS, is a technology that takes the exhaust that comes out of a power plant and it captures the carbon dioxide, which is a greenhouse gas, and pumps it underground. And there's been a lot of research on CCS. RPE had a program called Impact about 10 years ago looking at this, and there have been a lot of programs at the Office of Fossil Energy and the National Energy Technology Laboratory to develop CCS systems to make it lower cost, to make it more efficient, and there's been a huge amount of technical advances that have happened. But a lot of the work has really been at the individual plant level. So imagining a power plant saying, how can we build a CCS process that works as efficiently as possible at this one power plant? I was thinking, when I started thinking of Flex, I was interested more at the system level and what kind of value CCS would provide in a deeply decarbonized grid. So this is a grid that's already been largely decarbonized and it's getting close to a net zero carbon grid, and thinking about the system value there. And once you start thinking that way, the topic of renewables quickly comes up. So that future grid, it's going to have a lot of wind. It's going to have a lot of solar. It's going to have storage and demand side management and all this advanced technology. And those new systems are going to impact how power plants are built and dispatched. And it also affects how CCS should be designed and operated. And this is something that I mentioned in my fast pitch at the 2019 RPE Summit.
And as I recall, you managed to slip in two of your favorite things, Star Wars and Apple products, into that pitch.
This is the world in which CCS for power plants was first conceived. Now, the technology itself has grown by leaps and bounds. There's been enormous improvements in CCS technology, but the paradigm that this is something that we're going to bolt on to a baseload power plant has not changed since then. We need to update how we think about CCS, and I don't just mean update it for the world today. We need to update for where we think the grid is going to be in, say, 10 or 20 years.
Well, I was trying to be memorable, so I had to be honest and say, what are people going to take away from this fast pitch? They can remember me, or they can remember the Star Wars quip, and I had to begrudgingly admit that it was Star Wars. But the point that I was trying to make was that the idea about CCS has been around for a long time, but we really haven't updated how it might operate to reflect how much changes there have been in the system, especially with renewables and energy storage. So I was coming at it very much from the point of view of technology. So I was thinking, well, how could a CCS liquid solvent or a solid sorbent, how could those processes be more flexible? But as we started designing the program, I was a little concerned because sometimes people could get into crystal ball syndrome where they say, this is how I think the future is going to look. Or someone else says, well, this is how I think the future is going to look. And what I realized is that we needed a more rigorous way of representing what these future scenarios might look like so that we could provide inputs to our teams that were useful. And Max, that's where you stepped up and really made a big contribution.
Thanks, Scott. And I think one of the big things for any ARPA-E program is the metrics that go into it that we are really pointing our performers and applicants at targeting. And we knew that the technical community really just wanted technical targets. Tell us what the capture rate needs to be, tell us what the ramp rate needs to be, tell us what the costs need to be, and we can go out and do that. But we realized that we needed to change the thinking a little bit. In the past, carbon capture has all been about reducing the captured cost of carbon. So how much does it cost for each ton of carbon you put into the ground? What we wanted to do was come at this a little differently and say our goal here is to have the lowest cost, lowest carbon grid possible. And we think that CCS technologies can help contribute to that. But to be able to measure that, we need the tools to be able to understand how these CCS technologies are actually going to interact with the grid. So we actually went out and funded two teams. We funded Stuart Cohen at NREL and Jesse Jenkins at Princeton to build detailed representations of carbon capture technologies into the models that they use to evaluate grid performance and cost. And using those tools, we'll better be able to evaluate how the different technologies being proposed by the teams are likely to actually perform. And to that end, we were also asking the teams to put together multidisciplinary groups that could really think through both the economic as well as the technical challenges and put together robust analyses and performance metrics around that. So we're really excited that we're able to bring that all together.
Yeah, and in phase one of Flex, we funded 12 technology teams in addition to those two modeling projects that you mentioned, Max. And the teams are looking at a variety of approaches for things that we think could be valuable in the future system. So some of it is taking existing CCS technologies like liquid solvents or solid sorbents or membranes and making those processes more flexible. Some of them involve adding some kind of storage. So it could be thermal energy storage or storing chemicals like oxygen to allow the power plant and the capture unit to operate at a more steady state, even if the price of electricity is going up and down, and sometimes the plant would normally dispatch, and other times it might not. Having some kind of storage might help buffer that process so it actually doesn't have to be flexible if that storage is very, very inexpensive. And the other category that we're considering is integration of point source CCS, which is everything we're talking about now. Point source is like a big single emitter of CO2 with direct air capture, which is capturing CO2 directly from the atmosphere. And the idea here is that, particularly in situations where the power plant is on but turned down to a very low level because the price of electricity is very low and the plant doesn't want to shut off, but it's not really dispatching to the grid, there's electricity and there's heat available from the power plant, which direct air capture needs both of those things to operate. And so could there be synergies between a power plant at different states and a direct air capture system that could reduce the cost of both? We have several teams that are looking at those processes, and we're excited to see what they come up with. So I agree with you, Max. I think that having an interdisciplinary approach is really important. All of our teams have brilliant chemical engineers who have been working on CCS for a while, but it's more than just that. They have people that are good at optimization or people that are good at controls. And we mentioned this also in the fast pitch at the summit last year, talking about how important it is to have a really complete interdisciplinary team.
The last thing I want to say is what we're really looking to do here is bring different communities together. Historically, when people have done CCS from the point of view of a power plant, they said, I have a power plant, I'm going to assume it's operating most of the time, and I'm going to design a gas separations process that works for that power plant. People can do this. What we're thinking about is designing a separations process from the point of view of the grid. What is the grid going to look for? And so what we're looking to bring together are people that do CO2 separation technologies, but other things. People that work in co-optimization, I mentioned storage and direct air capture, plant dispatch, modeling, controls, a lot of different things. We're looking to bring together a lot of different disciplines to think about how these power plants might be designed and operated.
So I'm very excited. I think we're going to learn a lot in phase one of Flex. We're going to learn about what kind of cost and performance these CCS systems need to have to be valuable in a future grid. And then once we know that, in phase two, our teams are going to be building components and small systems and prototypes to really begin to show this and to prove that these systems work and that they are going to provide value in a future grid. So I'm feeling very excited about it. I think we're going to learn a lot. Max, I don't know, how are you feeling right now?
Yeah, I'm really excited. I think I'm particularly excited to share with the broader energy community how these purpose-built CCS technologies can provide benefit to the grid as a whole as we reach to go deeper and deeper decarbonization pathways on the grid.
Yeah, so we appreciate you watching this. As the Flex program progresses, we're happy to share more progress as our teams get underway. But we want to give you a little bit of sense as to what the program is and why it's a different take on CCS. So we're excited about it, and we appreciate you watching, and thank you very much.